Okay, I appear to be almost live. Takes a little while. Live. Whoa, didn't want to do that. Alright, take me a minute to get a few of these settings right. So, any early viewers, sorry. I jump ahead a couple of minutes and, for you people watching the recorded version instead of the live version, it's just all so whatever. Alright, so I have to find this on my channel. I have to do it in this other program. It's all so complicated. Really shouldn't be, but alright, so I go to this, which didn't work. Thank you, YouTube. I don't know why it won't just go to the channel. Yeah, it won't. Yeah, it won't go to my channel. Oh, I hate YouTube. I mean, it's all there is, but I mean, I do hate it. Let's see. I try to minimize what I have to type. I do that. Alright, so I go to my channel. I can't view anything in my channel when I'm signed into my account. So I have to sign into a different account to see my own videos, which is really, really annoying. Alright, I changed the date, but this is the right video. Really, really annoying. Okay, yeah, that's me. Alright, so now, don't forget your standard moderator for this channel. There, I'm a moderator. Cool. Oh, that is funny. I have to actually, yeah, I have to go to a different, well, anyway, you're not going to understand, but I have to sign into a different account to view the chat, because YouTube broke my Draft Science channel. So I can't comment anywhere on the internet using it. And to do that, I guess they had to break the ability to do a lot of other things. Anyway, okay, so I wonder if I have to play the stupid video for the chat to update. Well, hopefully not. Yeah, hopefully I don't have to play the video. Alright, we'll find out. So that would be silly. Yeah, stream the video and play the video. Yeah, we don't want to do that. Alright, well anyway, so what do I have to do else? I have to do something else. No, I don't have to do that. I'm done with that. Alright, I'll leave that alone. Let's see what happens. Okay. I wonder if I pop the chat out, whether it'll work better. Guess I should say live chat. Alright, and then, yeah, maybe I'll pop it out, see if it works. Pop out chat. Okay, yeah, it might be easier to view, and I don't have to play the video. That might be the way to go. Yeah, I like that so far. Alright, so, yeah, I guess we're ready to begin. Almost. Alright, so this is a video by, who the fuck is it? I forgot already. And so we'll play some of this video in between your wonderful commenting. Alright, so it says gravity is incredibly weird. Here's why. So it's a gravity video by Celestium. So he does mostly all this cosmological crap, and so I don't even consider that even as science. It really is just so silly, all this cosmology crap, because they have just Einstein all over it, and it's all this wooey nonsense. So it's not of much value from my perspective. There's no physics involved really. So they suck. Anyway, so yeah, I don't watch cosmology videos, because they're all just horse shit. Anyway, there's just no elemental physics in anything they talk about. They've lost the whole. Well, I mean, all the physicists have lost the whole theme, which is this idea of movement and matter. Two things, mass and motion. That's all there is. There's mass and there's motion. Alright, so I think before I do this, I will do a little bit on the drag subject, just because it's really incredibly interesting, frankly. And I have to concede, it's interesting to me because I've done something quite clever. That I've defeated Richard Feynman's superficial critique of Lesage gravity. So the only critique that Wikipedia really says, oh yeah, here's Richard Feynman, destroyed this idea. It can't possibly be viable because Richard Feynman said so. And it's not very smart, frankly. And you're just saying these are physicists, and they really should have thought about it a little bit. Frankly, I had to think about it a lot. But I should have to think about it a lot because I didn't go to college. I haven't spent my whole life immersed in physics. So it should take me longer, but it should have taken them almost no time to figure out that how fast I move into a particle field doesn't change how many particles I'm going to hit. Unless they were standing still, then it could matter. But if they're heading right for me, it doesn't matter. They're still going to hit me. Hitting them sooner doesn't change anything. I'll still get the same energy from the interaction. Nothing changes. So I thought of a way of explaining it, but I'd rather just, I don't, I know a little bit of programming, but I haven't done the learning curve on HTML5. I can't really do the, simulate a million dots and all that kind of stuff. I'm just not competent. And so the learning curve is going to be too high. I don't really have the time. I've got so many things to do. So I really can't learn how to do it. And so I need somebody else to do it. Now, I've had people work on simulations and, they run out of gas and life gets in their way and all that kind of crap. And at the moment, I'm a little dry on people. Some commit suicide. I can't, when they're dead, I can't really get much out of them. So anyway, it's all it's just so depressing, life. Anyway, endeavor to persevere, Gary. So let me see what this looks like, and I can figure out where I can draw. I probably should just remove the damn thing until I finish the drawing and finish this subject, and then I'll put that. Remind me to put that back. Alright, so the simple argument is you're an object, okay, and the simple Lesasian gravity argument. I hate saying Lesasian, frankly, because look, the guy who invented it is Fadio. Lesage just bought Fadio's paperwork from his family and just basically resold Fadio's work. So, I mean, it's just, it's just not fair to call it Lesage gravity when it's Fadio gravity. And he did, the fact is, Newton signed Fadio's theory. Okay, so he did like it. For a while, anyway. Alright, so you're a thing in space, and the idea is there's a bazillion of these little particles moving through space, okay, and they go the speed of light, and obviously the only ones that hit you are the ones that hit you, okay, so they have to be heading in some respect right for you, okay, so these are all, like, let's say they were tennis balls, alright. And the basic principle is that the system producing the tennis balls is fairly reliable. That is, there's the same stuff coming from one side. There's not an obvious bias. So if you were in the universe and somebody just put you somewhere between a whole bunch of galaxies and everything, it would tend to be, you wouldn't go anywhere. You would just, there'd be a little more energy. A supernova would go off. You get pushed a little this way. Then another supernova go off on the other side, and that would push you back the other way. And you're just going to oscillate. And how much you oscillate, it could be a significant amount of oscillation over time. And that's the thing that gives the whole thing away. So if you just counted all of these tennis balls, so if you just had a machine that produced exactly the same, okay, so let's say there's 10 and there's 10 coming this way, well then you get the idea that you're just going to be stuck in that 10 per second. Let's say it was 10 per second, okay, and that's a standard amount. And so you have this object and you're saying, well, okay, well now how can I make it move that way? And the simple answer is, well, I'll add one more tennis ball this way. Not one more per second, just one more out of the total. So you have a running total. And so the running total from this side, let's say we got up to 1,000, it'd be 1,001, and this side would be 1,000. You know, and if it got up to 2,000, it'd be 2,001, and this side would be 2,000. So you can understand, all I did was add one more tennis ball. And the fact is that one tennis ball, okay, because it was one extra on this side, the fact is I can't undo it ever until I add another tennis ball from this side. So if you simulated this, had a constant amount coming in, just added one more element on one side, this object will in fact just keep going this way in that field. It will do it by going and then stopping and then going and then stopping and then going and stopping. But that's what it's going to do. It's going to keep going. And it won't stop going that way until you add another tennis ball over here and make it 2001. You know, or let's say 7001. So you get to 7001 and then 7001. Now it'll stop. Now it's not going to keep moving. Now it's done moving. So it's clear that there's no drag. So even though it's moving into the field of energy, it doesn't matter how many, I could have 10. This could be 10 extra. Okay, so it's going pretty fast because 10 extra have stuck to it. And that's the idea here. So let me just explain. The rule is that if when the tennis ball hits, it sticks if the tennis ball isn't moving against it. So if it's moving in the same direction or not moving at all, the tennis ball sticks. If it's moving against the tennis ball as it hits, then they both reflect. That is, this one reflects and this one reflects. And yeah, that's all you need. So you either have a reflection or an absorption of the tennis ball. Okay, so it's that simple. It either sticks or it causes a reduction in the momentum. All right, and those are the only two rules. So the whole idea is that I can't move into more tennis balls. I can only hit them sooner, because the ones that went faster then are going to catch up, and they're going to equalize what I lost plus that extra one. So that extra one can't go away. So I'll basically go into more pressure, hit it sooner, right? But that's all I'll do is hit it sooner. It was going to hit me anyway. And then that'll slow me down. It might even stop me. And when it stops me, the stuff I'm going ahead of will hit, and it will re-add that one again, because the one is in the field. So you can't be dragged. Okay, so you really have to have an opposing extra force has to stop you. The same force, me moving into the light bulb, I can't, well, the fact is I'm going to hit more photons, so it's not a good example, right? Because as I move into the light bulb, I'm going to hit more photons because I'm changing the cone that's going to hit me, right? So that's not a good example. But if it was a laser beam, okay, I can't make more laser beams. So if I have laser beam shooting this way and a laser beam shooting this way, I can't make more laser beam by moving into the laser beam sooner, because all of this is still going to hit me. I haven't changed anything. Really important argument. This is gigantically important, and the fact that they've never simulated it, never even tried to draw it or mathematically think about it and say, yeah, if I add one more tennis ball, I can never undo it. It's on this side. I can't undo the fact that this side has 1,001 and the other side only has 1,000. Can't undo it until I add another one over here. Really big. Oh, the smell of skunk. How charming. Yeah. It's really quite urban here. You know, it's surprising what animals can survive. I wouldn't, you know, that you just wouldn't think would be able to eke out an existence with all the cars and the shit. All the smelly humans. Alright, anyway. Okay, so that seems like enough. So we'll put back this. And we'll see if the chat thing did anything. Let's see. Yes, I can actually see something. Alright, so which chat is first? Love the beginning. Well, I don't know. We have mass is also motion. It's all motion. Well, I'm sorry, it's not. So I'm just, if you can't sit there and concede that, you know, you really can't just say motion, because big things, small things create a huge difference in the fact that they're going to convey something different. So the mass is integral to making the motion significant. So you can't just say it's all motion. You know, energy's all motion. You could say that. Okay, that's all about motion. Something interesting happening requires motion. But there's no point in just saying, I'm just going to pretend there's no mass being moved. It really is just a Sisyphus argument, okay? In my previous example here, the tennis balls are the Sisyphuses. The thing getting pushed, okay, is the boulder. And it's just a matter of what Sisyphus has pushed it and which ones, you know, has it exchanged Sisyphuses. You got Sisyphuses coming this way and Sisyphuses coming this way. And the fact is they're going to have a competition, and frankly, the side that has 1,001 Sisyphuses is going to win. Now, I don't know, you're not even motion loops. What the fuck is this shit? Please go away, okay? These 3-word physics theories are of no interest to me. Motion loops. Fuck. God. Oh, God, I hate flat earthers. Hate them. I mean, it's the same thing, right? I mean, these people that spend 4 minutes thinking about something and, you know, combine 2 words, motion loops. It's worms, okay, with their eyes in their anus. So they have to open their anus to see, and that's the worms that are the strings. So there's not string theory, it's worm theory with their eyes in their anus. I spent 4 minutes making that up. I'm a scientist. Fuck! It's just such noise, these stupid noise makers. I have a theory that doesn't make any sense and can never work. You want to hear it? Shit. So I understand why people, like I said, they can have a first impression of me and say, oh, he's one of them. Well, I'm not. This is not a worm theory. What I just described about drag is an absolute fact. If you actually spent a little time thinking about it and drawing it, and if I can get somebody to make the simulation, you'll see. It actually happens. There is no drag when they're getting hit by tennis balls moving the speed of light. Yeah. Alright, anyway. So leave us begin playing this moronic video by this moronic English person. So, the problem's going to be, I won't understand a damn thing he's saying, because he's speaking English. Damn! And he's got his video, it's all this production shit, right? So he's got his voice sped up a little bit, and he mumbles a little bit, so, hopeless. So there'll be a whole bunch of little phrases I'll miss entirely. But we'll give it a shot.
The image of an apple falling on Newton's head. Believe that you understood gravity, chances are that you couldn't be more wrong. You see, gravity is one of the most misinterpreted disciplines of science.
It says him, right? So he's one of the... Oh, I forgot about that. Shit. The evil
Imagine you were an astronaut.
Oh, and it jumped to a different video. Isn't that just so fucking special? I hate YouTube. Ugh, this is such a pain in the ass. Oh, god damn it. I mean, it's just a simple procedure. Just play the fucking video and, you know, now I don't even know where the pop-up window is. Where the fuck is it? Oh, I have to hit the play button. Oh, okay.
If you've seen the...
Oh, shit. See, I want to be able to control the volume and different things, and so I can't use the pop-up window because it only has a play button. Anyway. Alright, we'll try again and see what happens. See, it won't play. It won't play unless I hit the play button. You can't just click it. Alright. And obviously I'm not using the keyboard, so I can't just keyboard it. Well, anyway. And then it shows all this little crap.
Believe that you understood gravity, chances are that you couldn't be more wrong. You see, gravity remains one of the most misinterpreted disciplines of science.
Okay, so he knows what it is, but all of them has misinterpreted. And the idea that it's just this idea of something moving, okay, is the only part that's you need to understand. And then the inverse square part is just the same thing photons is doing. So you just say, okay, a light bulb is doing the inverse square law, so all I do is reverse the light bulb and have the photons moving towards the object, and it's exactly the same force scenario. So you have this quadratic increase in this squared increase in your capacity to get hit by photons the closer you get to something because of the pushing force. So all of that works perfectly. Right, so that is quite sensible and easy to understand. So, you know, to sit there and think there's something else really happening, that there's, you know, this is actually a pulling thing, something's pulling me, there's nothing pulling me. I'm being pushed into the earth. It's just kind of obvious. I don't even know why Newton was confused, frankly. I mean, the comparison to a candle, I mean, you know, you can see the aura around it. I mean, just the whole idea of understanding that more photons hit you the closer you are to the candle. And you're just saying, well, what's the reverse of that? Just really disappointing. All right, so I do have to figure out how to do
Science
this.
can measure and predict gravity's effects. What gravity actually is on a subatomic level continues to be one of the greatest unsolved mysteries of our time.
All right, so what they already know, it moves the speed of light. And they know magnetism moves the speed of light. And electricity, depending on where it is, moves the speed of light. And light moves the speed of light. So they know all of this stuff that's going really fast is going the same really fast speed. And that all of the matter stuff can go variable speeds. But it's unlikely that you're going to get all the way up to the speed of light. So those are the facts. So you really should be able to figure out there's something called force and there's something called matter, elementally. And that forces, okay, can make things move. You can shoot a laser beam at something and push it, actually. You know, obviously you can push something with magnets, no problem at all. All right.
Even what we do understand about gravity's characteristics defies conventional expectations.
Okay, so that's the funny part too. Well, even though what we know is somehow defies expectations, it's not that complicated. You know, what goes up gets pushed back down, and it's so regular and perfect in terms of, you know, the simple mathematics that describe it. It's just so simple. So what is all that hype about?
The phenomenon...
I don't think this guy is actually a scientist, right? He's just a presenter for other people's bullshit. So there's this whole network on YouTube that produces all these different channels. And, you know, it's really not about these individuals. It's about some group that's created this persona, you know, to make money. It's not even any kind of sincere science. It's a program designed to make money.
it creates range from the bizarre to the downright fantastical.
So whatever. So all of that crap is not stuff you have to even consider as part of this subject. The existence of black holes, all that crap. doesn't mean anything. It doesn't really have anything to do with the subject. It's all speculation about some kind of magical event where I've got all the matter in one location, like somehow I can pile them all on top of each other, and they're all perfectly satisfied to do that. You have to believe a bunch of sissy crap, in my opinion. This is just wooey crap. This is not real crap. It's just their daydreams.
Gravity is responsible for your perception of time. That's just
So again, there's no perception of time problem. We perceive it perfectly right. Okay, 5 trillion billion light years away from here. There's time. It's the same time there. It's the same time everywhere in the universe, and it ticks exactly the same way, and all of that happens. And the only argument is that for you to transport to one place to another, you have to do it at this very slow speed, the speed of light. It's a lot slower than instantaneous, right? So just understand, it takes billions of years for light to get across the universe. Obviously, it's not going that fast, but it takes billions of years. It's fast compared to how fast I can stick my finger in my eye, but it's not very fast compared to instantaneous. It's insanely slow. So, and so that whole process of speeding you up means that all of your little bits have to go one speed in one direction. All right. I don't think the atoms would even hold together, so I don't think it's even a reasonable conversation that can ever take place. But whatever. I mean, the electrons, if you push the electrons, then the protons have to be dragged along, which means you have to use some energy to move the protons. So, there's just no way to figure this out. Frankly, this really doesn't work. This idea that you're going to get matter going the speed of light. And anyway, it's not even a worthy subject. I mean, talking about time dilation at near the speed of light has nothing to do with gravity.
To the iceberg, the deeper you look, the more you realize that gravity isn't merely weird. It sometimes seems almost magical.
Oh, isn't that frightening? That's science. So there's nothing, I'm just saying, it's nothing weird about it except the fact that, yes, you can make intuitional mistakes. So, like I said, Fabio presents this idea of an ultramundane particles creating gravity. Perfectly sensible, duplicates the inverse square law. So if I simply said there's a bunch of little tiny particles called heat in the universe, cell phone calls from Venus, who cares? A bunch of photons, broken photons, little bits moving the speed of light. And the simple argument is it automatically creates the inverse square law, so I don't even have to worry about that. Okay, they're going to hit the Earth. Okay, and they're going to hit it symmetrically and spherically, so it's going to be the inverse square law whether I like it or not. And all the gravity is really the idea that somehow, these particles have a harder time getting through the 4,000 miles of the Earth. And you sort of just say, duh, I think it's 4,000 mile diameter. Yeah, duh. So yeah, it's really easy for the photons to hit me from the top. It's really hard for the photons to hit me from the bottom. That's gravity.
As for the ongoing scientific mysteries, we obviously can't provide definitive answers since the brightest minds in the world haven't cracked the code yet.
Okay, so they haven't cracked the code. They have to do all of this bullshit for the simple. It's a very simple formulaic thing. Okay, you have a gravitational constant, and all you can do is really just multiply the times the mass, and you get a number, and that number is basically how much gravity you're going to have at a specific location. Not really complicated. Nobody in the chat. Okay, surprising. Is anybody in the room? Yeah, I guess I could look. Is there a point to looking, Gary? I don't know. Might frighten you. It doesn't tell you here. Interesting. I thought it told you how many people were watching. Don't see that anywhere. Let's see. Yeah, I don't know. Strange. Yeah, okay. So I could go to the streaming video. I suppose I could find that. Where am I streaming from? Here. There. Alright. 5 concurrent viewers, 13 views altogether. Okay. So there are people here, they're just not chatting. Okay. Got it. Maybe. Possibly. There's no reason for the chat to break, right? I don't think there's a reason. Alright, we'll assume it didn't break. So, continuing.
Since we're not up there with them. What we can tell you is that investigating gravity is enough to make you question reality.
Okay, so investigating gravity makes you question reality, like I said, and it's really not that complicated if you just concede that, yes, the simple model that there's paint spray or rain coming down on you, and that gives you momentum. So there's a real force, it goes through you, pushes your matter, and it pushes it evenly. That is, it pushes every part of you equally. That's why you don't feel being pushed by gravity. And the thing you're really feeling, you know, me sitting here, I can't feel the gravity pushing me down, but I do feel the earth pushing me back up, because the earth isn't creating that kind of a force. It's pushing me up with hard atoms. Okay, and it's pushing me from one location, my ass, at this moment. And so that's what I'm feeling. I'm feeling getting pushed back up. I'm not feeling being pushed down, which is the interesting part. And so that's why there's no true equivalence between being in an elevator and, you know, all these examples they give, because the fact is, I'm just trying to think. Yeah, the space example of being accelerated by being hit by the floor or being hit by the ceiling is quite different than gravity moving you.
Perhaps even enough to make you throw away your bloody clock.
This is really irritating, so I don't know if I want to go to the trouble of downloading it. Well, I can't really do it now, so we'll just have to endure the commercials.
Plymouth Rock, I never wonder if I'm covered for home and off.
Fuck you,
More
fuck you,
savings,
fuck you.
more coverage.
Fuck you, fuck you.
Gravity is inexplicably weak.
So again, this is a standard thing they say, and so obviously it's not a weak force, because obviously gigantic things are being moved by it, so it'd be kind of silly to say it's a weak force. They're making it weak because they're comparing it to the actual source of gravity, which is charge. So the real interactions are happening between electrons and protons. So obviously in that tiny universe, that's a very strong force between them. But you know, when you go this far away, you know, and from those little tiny interactions, obviously it's a gigantic difference in distance. You know, the distance between an electron and a proton, or the nucleus of an atom and the electrons, and the distance that we are from the matter. So obviously, yeah, it can't reach us, but it's not a weak force. It's the same force. It's made out of the interaction between force and electrons and protons. There's no other interaction that takes place. There's just matter bits and then the force bits. And the force bits push the matter bits and push-averse. Not complicated. It's really not complicated. Alright, what does this guy say? Magical is something scientists shouldn't say, especially one describing gravity. Yes, I mean, the fact that they use these words that really should be just taboo. They use random a lot. So instead of saying like random or random-ish, okay, or some version, they say the word random, and you know, there's no random anything. There's no such thing as a random, just as there's no such thing as a spontaneous, and they still use that word. They're physicists. They know there's no such thing as a spontaneous. There's no such thing as something that happens without a cause. Okay, it's a cause and effect universe. It's a mechanical processes have to take place. You can't just say it automatically poofs something. So even the decay of an isotope. I mean, what, they think it really just says one day, I can't take it anymore, I have to explode. No, that's not what happens. There's some event that's very unlikely to happen, okay, that happens for uranium, it happens every 10,000 years on average, okay, they roll snake eyes, so to speak. I mean, it has a dice with 10,000 possibilities on it, and it just takes these 10,000 years to get to the inevitable consequence of you rolling your snake eyes, of being in a configuration that, and obviously you can change the half-life of uranium by just putting a bunch of uranium together. So it has to be a process. It's not something built into the atom. The atom hasn't got a time bomb inside of it saying, oh, I'm going to explode, I'm going to explode. No. It's obviously environmental. The environment is doing something to it, just like humans getting cancer or something. The shitty environment does something, and it happens a certain number of times per million interactions. And it's just, the way it is. But yeah, there's nothing spontaneous. I mean, no scientist should use the word. I mean, look, I've made the mistake of saying the word because it's ingrained in our vocabulary. But I've gotten so much better understanding my obligation not to use terminology that's bullshit. So I usually don't say the word random without saying, I have a phrase and I just can't remember it, random-ish or something like that. Some qualifier to say it's not random. All right, continuing.
Despite being the primary governing force of the universe on a large scale, gravity is almost...
All right, so there's no large scale, and there's no forces, there's no laws of physics on the large scale. There's only one universe, electrons, protons, and the force. That's the only universe that's real, and that has real properties and laws built in. The electron has real properties, the proton has obviously the real opposite properties, and they react to the same force in opposite ways. And that's the simple mechanics, and that's the only universe. That's the one where the empty space is real. That's the one where there's actors doing something. And everything happening here in this bigaverse, okay, is just a byproduct of what happened there first. So nothing here controls the electrons and protons. It just doesn't. They control us. We don't control them.
Inconceivably weak. As most are aware, gravity occurs whenever there's an accumulation of mass. The more mass an object has, the stronger its gravitational field becomes.
So these are idiots who believe in black holes and singularities. That's another word shouldn't be used. They believe that you could pile 1 million electrons into the same space. Obviously, that force would be incredibly strong, but we know that, of course, it can't survive distance. So, it's not that complicated an argument just to say, well, it's strong, but if you're too far away from it, yeah, it's going to be quite diluted. All right, so the model you propose for gravity is actually something I'm surprised established physics hasn't already come up with. Well, it has, but it like I said, the key thing was the drag argument. So the argument I made in the beginning of this video is the only significant argument against it. I mean, actually, the Wikipedia page on Lesage gravity would actually mention heat. And I found that one so funny. Like, oh, it would create heat. That's exactly what's happening. The Earth's core is 4,000 degrees. I mean, it's hot as hell down there. So, yeah, gravity creates heat. The sun is on fire. Yeah, gravity creates heat. Duh. It has to go somewhere. It's a ton of momentum. Acceleration is momentum. Do you understand? So even when you're on the surface of the Earth, you're pushing into the Earth, right? Over your lifetime, 200 billion joules of energy is being pushed into the Earth by you. Okay, so it's a ton of energy. It has to go somewhere. It can't just not go anywhere, right? You can't kill energy. So it has to be dissipated as heat. There's no choice. And the fact that they haven't figured that out, that the universe is, say, 50 degrees Kelvin. Let's just say that if you just go into empty space somewhere, you will be 50 degrees Kelvin because of all the shit hitting you, the photons. You know, if you add up the microwave background, which is 2 joules, and you add this, and you add that, and you add this, and you add that, all the broken photons, it's 50 degrees Kelvin. So if you think about the surface of the Earth and say, well, what happens if I hit 50 degrees Kelvin across the entire surface of the Earth? And it's constant. I keep feeding that temperature into it. Well, the fact is the tiny center, right, is going to have to magnify all of that heat, right? As you go halfway through the Earth, it gets twice as hot, and then 4 times. No, it's the inverse square law again, actually. So you go half the distance, and it's 4 times hotter. And then you go half that distance, and it's 4 times, and it just keeps getting hotter and hotter and hotter. So that's how the Earth gets 4,000 degrees in the center, is because the surface area is 4,000 times smaller. You've applied the heat to now a much smaller. All of the heat is on one smaller surface. I mean, yeah, it's so it's just so simple. It's just amazing that physics could make such a mess out of everything. They destroyed every single subject with this wooey crap, these silly dualities and nonsense.
Taking Earth as an example, the gravity produced by our entire planet is remarkably faint. Every time you pick up an object or stand up from a sitting position, you're effectively winning a tug of war against Earth's gravity, and it's not taking much effort at all.
Alright, so we know, look at the stupid, we launch a rocket to get into space, and it makes like, for that year that we launched the rocket, it's like 1% of the pollution on Earth or something. I mean, it's this huge amount of toxic shit produced because we have to pile so much energy into that rocket. And he says it's a weak force. I mean, it's too silly. And like I said, if you're going to compare the tiny universe, against this big universe, then all the proportions are, 10 to the 40th or 10 to the 30th out of line. So of course you're going to be able to make some statement that the force between the electron and proton is stronger. It's not really stronger because the electron is it barely weighs anything at all. So you know what I'm saying? You're pushing something insanely light and then comparing that to pushing something insanely heavy. You have, I can't even describe how many electrons you have inside of you, right? An apple is to the Earth what what an atom is to an apple. Well, can you imagine what an electron is to an apple? I mean, come on, it's an insane density, and he's saying, well, they should behave exactly the same. A gazillion electrons should move just as fast as one. No, that would be kind of silly. No, it'd be kind of goddamn stupid. It's just horrible living here with these people. It's just saying all this crap that just isn't true. Very annoying. I'm going to try to get some nicotine here. Yeah, it's very good. No. Don't get addicted. Mistake I made when I was 11. Alright, we'll play some of him while I, do my, feed the need.
Keep in mind that this weak force is generated by a mass of 5.97 septillion kilograms. That's a number with 24 zeros behind it, by the way. On the other hand, Earth's gravity is powerful enough to keep the Moon in orbit, while the Moon's gravity, despite its significantly smaller size, is influential enough to drag the ocean in its wake, creating tides. Tides result from the interplay between Earth's gravity and the Moon's gravity, yet a contradiction remains. Is gravity so weak as to be almost negligible, or so strong that it can shape the entire solar system?
Oh, yeah. So is this the important question? So does this, this whole idea of making some dopey comparison between, well, is it as strong as a 5-year-old girl, or is it as strong as a 70-year-old man? Why? What is this? Well, who cares? Is this some significant fact somehow? To sit there and make these comparisons. I mean, the same 5-watt light bulb, right? The light bulb that's spreading its energy all over the room. Okay, it looks okay. It's insanely weak by comparison to the 5-watt light laser beam that'll burn a hole right through you. So yeah, it's a silly comparison, right? Because you're saying, yeah, well, all the photons are concentrated. So what the hell? Why would I make this stupid comparison and say that light bulbs are weak? They're not weak. It's that they're heating everything in the environment, not just one thing. I mean, it's just such crap. It's such distracting nonsense. It's not even a subject. I mean, comparing something, 10 to the 30th smaller, to something 10 to the 30th bigger is just retarded.
Gravity is both nearly inconceivably weak and at the same time by far the most prevalent force in the known universe. The best way to fully appreciate what gravity is, how it fits into the grand scheme of the cosmos, is by comparing it to the other fundamental forces.
So, again, that's not the way to do it. The only thing you need to understand is it's going the speed of light, which means, hell, it would be really coincidental that completely different things are going exactly the same speed. So that logical intuition you shouldn't discount until you have good reason to discount it. You shouldn't think gravity is something completely different, without a very good reason. And there's no very good reason.
Electromagnetism, the weak nuclear force, and the strong nuclear force.
So we know, so there's no strong and weak forces. So that one's the really funny one, right? Because, I have explained this one over and over again. But it's just so obvious. And you say, why did physics reject the obvious answer to come up with a fake, phony thing? They can't even, again, it's like the bent geodesic. They can't explain the source of the strong force. And the only way they can do it is with some wacky thing they invent, like a gluon or something that, is like a frog. It shoots its tongue out at the proton, and then the tongue sticks and then it pulls the... I mean, it's ridiculous, what they describe as a mechanism. So, I mean, this it's just... There's nothing, Maxwell gave you this, okay? Maxwell basically told you, look, there's call it thing negative charge and there's positive charges. And these basically, okay, Maxwell said there's no magnetic monopoles, but I'm just saying, obviously you could just look at that and say, okay, it's the same thing as a north and a south. And so, what do I do? If I want to get two South Pole magnets, I want to get them really close together, how do I do it? What's an easy way for me to sneak them really close to each other? Well, I just stick, I stick an electron between them. So if I have two protons, what do I need to make them get really close together? Oh, damn, I drew it in the wrong place. All right, so proton. They're far away. I want to get them really close. What do? I just stick an electron between them. Problem solved. They already know what's going to happen. Oh, well, the proton's going to fly into the electron. This proton's going to fly into the electron. So what do I need a strong force for? It's really easy to get two protons really close to each other. Just stick an electron there. Now, the irony is that Rutherford, who really did all the discovering about this elemental atom stuff, his diagram of the nucleus has these electrons in it. He believed it was a composite nucleus that had protons and electrons. It has twice as many protons as it does electrons. And so it's a composite object. And so from certain places it's going to look positive. From other places it's going to look negative. Because it's not a big red thing. It's net positive. It isn't intrinsically or elementally positive. because it still has these electrons in it. And it was Bohr who ruined everything and broke everything by, making up this fake idea that the nucleus is just a bunch of protons stuck together. And the neutron, they already know neutrons decay into a proton and an electron. So obviously a neutron is just this. It's just an electron and a proton very close together. So I put an electron and a proton very close together. I get a neutron. Not complicated. I mean, it really isn't complicated. And you can understand that if I had them very close together inside of a nucleus and I took the neutron outside the nucleus, that the field energy is going to get more variable outside. And so these two things are going to start vibrating like this, okay? And so they're going to start getting out of alignment. And the more out of alignment they are, the less they can stick to each other. So if I take two magnets that are attracting each other, I think I can produce this. Okay, so I have two magnets that attract each other. The fact is, if I do this to them, okay, the attraction is reduced. The force pulling them together is weaker. Okay, so you can sort of understand that, yeah, it turns into a hydrogen atom. Neutrons turn into a hydrogen atom. Not complicated. So that's simple answer. They reject for some unknown reason and instead go with some notion that there's some new force, some special thing called the strong force, whatever the fuck that is, okay, that magically pushes protons together. It doesn't happen. It's stupid. It's a dumb answer. It's wrong is what it is. It's certainly incomplete, okay? It's an insanely incomplete theory of a force. The strong force. No mechanism, no mechanism that's anything other than just make bullshit up. It's no better than Holy Ghost.
Although gravity isn't a force in nature by the same description, we'll get to that particular mind-boggler later.
So whatever that is, obviously, but I'm just saying, it was always a force for me, okay? I could never imagine it as anything other than a force, okay? It was never a pull. It was always something has to be raining on me.
With the strong nuclear force, the strongest in nature by far, it is the force that binds protons and neutrons together.
So again, and bonding protons and neutrons, again, is just as simple as adding another proton to a neutron. It's just saying that you have a neutron, a hydrogen atom. I make it a very tight hydrogen atom, neutron, and I just stick another proton on this side. And it does give you a mechanism to build the next stage, which is the helium nucleus, because, you already have the 2-4 thing happening. 2-to-1 thing happening. And so you can just build the helium atom now with the 4 and the 2 electrons on the outside. And so you have 2 electrons out here, and you have 1, 2, 3, 4 protons. And that works perfectly. These 2 electrons can't get closer, okay, because they repel each other, but they're attracted to the 4 protons, so there's a balance. And the protons are attracted because there's 2 electrons, but they can't choose which electron to go towards. So they're stuck. And they repel each other, so they can't get any closer either. They can't move in, because, I'm going to be closer to the other proton. So I'm just saying it works really well. But no, let's just fuck a rational model and go with mush. Alright, let's see. We have another chat whore. Oh, it's Dark Guy. Scientists should look past your character. Fuck you! There's nothing wrong with my character, frankly. But whatever. And just look at your arguments. The whole point is you really think they're afraid of my character? Do you think they're afraid of, a wacky flat earther? Like, say if I was a flat earther. Do you think they would be afraid of trying to mock me? Do you think they would have any apprehension about making a video mocking me? It's not about what my character is that scares them. It's the fact that they don't have good counter arguments. And the fact is they won't be able to mock me successfully without completely cheating anything I said. 95% of what I say is absolutely perfectly stated. Okay, 5% is a little shitty. Okay, sloppy. But it's just a fact that if I say something like there's only one universe, the little tiny one with electrons and protons in it and a force that moves them around, they're not going to be able to make a counter argument saying, no, that can't be the truth. We've proven there's no tiny universe. They can't do that. All right. So, you shouldn't imply that this is about my character. They're afraid of the arguments and using my personality as some sort of excuse to run away. And that's all it is. It's just an excuse to run away. And it's just an excuse because, like I said, if I was saying anything other than the truth, they would attack me. But the fact is they can't attack me because I'm not wrong. I'm absolutely right. I'm absolutely right that the easiest way to get two protons to get them to get two south magnetic poles to get them close together is just to stick a north magnetic pole between them. It's a very easy way to get them very close. Back to the video, yeah.
Protons carry a positive electrostatic charge from electrons and are naturally repelled from one another under known circumstances according to the laws of electromagnetism. However, the strong nuclear force overcomes this natural repulsion, allowing these particles to bind and form more complex structures. On a deeper level, this process is regulated by gluons, which mediate interactions between...
So isn't this it's just such mush, right? The simple answer is a neutron is an electron and proton. That's what it decays into, right? Is there some point in saying anything else? I mean, they say it also includes, right, the decay produces an anti-neutrino. Okay, but, neutrinos are so weak that who cares? But the very fact that they claim it, and there's no evidence. But anyway, it's just so obvious. I'm just saying, it's just so obvious that the nucleus really does have to be made out of, there has to be electrons in it. How can the neutron decay into an electron and a proton if there's no electrons in neutrons? I mean, it just doesn't make any sense how they can't just add 2 plus 2 here and leave it alone. Why do they have to add 2 plus fairy plus gypsy, plus pixie, plus hobgoblin plus 2? Why all this crap? Why are these hobgoblins in the formula? I mean, it's just so, I'm sorry, scientists are stupid. There's no other why would they fall for this shit? Oh, my professor told me so. It was, that's what they tell you what the truth is, and then you recite it. Isn't that what being educated is? I'm well educated. I can't think for myself. All I can do is repeat what I've been told to say. Babble, 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 babble. Glue on, poo on.
Quarks. Most importantly for our comparison, the strong nuclear force is about 100 million trillion times stronger than gravity. It's quite strong. Despite its huge strength, it only operates on a subatomic scale, having a range limited to the nucleus of an atom.
Yes, the nucleus of the atom. It can't go any further than that because it's magically incapable. It's got an impotency problem. What is this? I mean, it magically ends. The force just magically stops. Inverse square law, Smurf. Yeah, I mean, it's just nothing applies. No consistency at all. So they understand that all these other forces, you really can't they just can't stop. There's rules to how they end. No, it just ends at the end of the nucleus. It just goes away. Poof. All gone. It's just so stupid.
The weak nuclear force is responsible for radioactive decay, playing a major part in both nuclear fission and nuclear fusion.
Alright, so just absolute bullshit. They've changed what the weak force is supposed to be over time 1,500 times. There's no such thing. There's no such thing. I mean, there's no... What do you mean? Responsible for nuclear decay. What the fuck does that mean? Nuclear decay means an atom's nucleus is unstable, okay, and it can fission. It can split apart because there's a point where there's got a weakness. So like the Death Star, you know, where you could just shoot a blob into a little vent and it goes down and blows up the Death Star. Yeah, radioactive isotopes have a weakness, okay, that over time eventually will be exploited by the laws of probability. And the fact is that if I put a bunch of those Death Stars together in a group, somehow it happens more often. So obviously it is some environmental event that takes place that causes the event. And this weak force crap is just that bullshit. Oh, it's just amazing to get away with this crap.
It's mediated by particles called W and Z bosons.
Oh, yeah, W and Z's. Z. What the hell is that Z? I mean, it's just, jeez. Oh, it's just so funny how somehow in America we figured out, no, it's a Z. It's not a Z. Z isn't a word. What the fuck are you calling something a Z for? That's just retarded. And cookies aren't biscuits.
It's about 1 million times weaker than the strong nuclear force operating at an even shorter range. Yet, despite even having the word weak in its name, the weak nuclear force is still stronger than gravity by 10 to the 25th power. That's 25 zeros. The last force
Made up
is
crap.
electromagnetism, the one that we are most familiar with given its tangible role in our everyday lives. As mentioned earlier, electromagnetism is rooted in the inherent properties of electrons, which are mediated by photons. When harnessed, these forces give rise to modern wonders such as electricity.
Right, and the simple argument is that what does a photon have? What's its property? A frequency. Ooh. Well, how do I make a frequency? You know, a period between events. Well, I could shoot bullets at, you know, half-second intervals. Or I could shoot bullets at 1 second intervals. And then I could have red bullets, and then I could have blue bullets, you know. I mean, it's just so obvious that, you know, the frequency is the distance between these quanta, as they call it. They call it quantum mechanics, but they don't believe in quanta, right? So Einstein basically said, yes, photons are discrete. They're made of discrete stuff. Now, he didn't say exactly that a photon was a composite object because he only wrote one fucking paragraph in his paper. But you could imply it pretty obviously that a photon is an event. It hits the surface and it causes electricity. And the irony is that you can make a photon by shooting electricity up a wire. And so the electricity is going at pretty high speed, almost the speed of light. So it's going really fast. And so it squishes atoms as the electricity changes their shape. So the electrons pop out, pop out, pop out, pop out. They push on this force. You know, they hit it sooner than they would have, causing a reflection sooner than it would have happened. And so now they've compressed the force in the field. You know, they've made these little dots. So this came in, these random dots, and this came out, these dots at a frequency. And they're polarized. That is, they came out in order. And now they're going to hit a surface, and they're just going to duplicate the same effect on the atoms. So the atoms over on this side were misshapen by the electricity, and the ones on this side are going to be misshapen by the force hitting them, and they're going to duplicate the electricity. I mean, it's so obvious. God damn. They're just so stupid. Simple, obvious answers. Okay, the photons aren't doing anything magic, and they're not actually being produced by the wire. The wire's just reflecting the universe, just like you're reflecting light right now. The wire's just reflecting the universe, and the fact is, when electricity is traveling through it, it's changing colors, and then it sends that changed color pattern. I mean, I can't say it. It's not really color, but I'm just saying that's what the frequency represents, is a change in a frequency, a pattern that's going to hit the surface, and some patterns will cause the electrons to move, and other patterns won't. And so if I push a kid on a swing and I push the kid when he's swinging back, I'm not going to make the kid swing more. I'm going to take away its energy. And likewise, if I push while the kid is moving in the same direction, then I will add energy. So obviously it's just a tipping point argument. If you hit with the right frequency, you create electricity. You hit with the wrong frequency, you don't. Duh. Da 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 da.
Although electromagnetism is weaker than the strong nuclear force, it is the only other force that operates on...
So electromagnetism is charge. Okay, it's the interaction between electrons and protons and the field. The electrons and protons inversely react to the field, and that's an elemental function that runs the universe. So everything is an expression of charge, ultimately. That's the properties of the electron and proton. Those properties are the cause of all the effects.
Grand scale, making it highly visible in the physical world. In fact, electromagnetism is stronger than gravity by 10 to the 30.
So he just keeps doing this, right? The whole video is just some diatribe about how, charge has a bigger penis. A lot bigger. What the hell is the point of this? I mean, it really is. What is the point of emphasizing this nonsense? They're two completely different perspective places. One with gigantic, insane amounts of mass, us, okay, and a universe with things with tiny, insanely small amounts of mass. Oh, and I have a big surprise that, yes, the tiny verse needs a tiny amount of energy to move things, and the big universe needs a ton of energy to move things. Duh!
Power. If you want a demonstration of just how powerful it can be and the vast scale on which it operates, just take a look at the compass. Regarding its range, electromagnetism shares a rather profound characteristic with gravity, but we'll refer to that in just a moment. Now, getting back to gravity, consider everything that we've discussed so far, keeping in mind how much weaker gravity is than every other force of nature. And now,
we didn't discuss anything, okay? You just gave me a bunch of propaganda, and that's all that happened. There's no discussion here about, well, that sounds crazy, Mr. Baldy. Do you have a better answer? I mean, that frog tongue gluon-y thing, do you really believe in that? That would be a discussion. You really think that's somewhere close to a plausible explanation? Yeah. Sounds like complete made-up shit to me. I mean, it's like a Holy Ghost with horns or something. I mean, right? I mean, you could just make it into anything, couldn't you? You could make any old hobgoblin. You could describe any kind of little hobgoblin and say it did it with its magic big feet. It kicks the proton into the other proton with its big giant feet. You can make up any fucking story.
I appreciate that it is the force responsible for creating galaxies, forming solar systems, and ultimately governing life as it exists on Earth.
Oh,
Without
what
gravity,
religious
it is
mushy
safe that
mush.
The universe would consist merely of particles floating in a featureless void, lacking any physical structure, and by extension, lacking the natural...
Right, so the physical particles, the electrons and protons, actually are like that. They're just dead. They can't do anything. So you almost could say they're dead force. You might even imagine that might be a possibility, that when forces do coincidentally hit each other at exactly the same time, that they just die. They can't move. And so they become an electron or a proton. And so the universe makes 5 of them every billion years or something. You can create all kinds of scenarios. I can make up stories. But the truth is that is the universe. The universe is dead electrons and protons and a live force that pushes them around. Fact. I'm sorry, it's the absolute fact. And you people are all full of shit because that's how it actually works. Because that works as a model and you can't get simpler than that. It's as simple as you can get and it actually works. Occam's razor, I win. Let's see. Character wasn't the right word. I guess look past the messenger and look at the message. You keep saying that there's something about the messenger that needs to be looked past, and it doesn't. Who cares? What is the messenger going to do? Am I going to burn down their house? I mean, what's this scary thing I'm going to do? He's going to call me a boogerhead. Oh! Panic! I'm scared! He's going to say I have a micro penis! Oh! Wait! What the fuck are they afraid of? They're atheists. What, they really think I'm a demon? And when I say, get what you deserve, that somehow I have the power to make them get what they deserve? Do they really think I have the voodoo power? So just quit talking about the fucking messenger and just concede. They're afraid of the fucking message, and that's all this is about. They are not afraid of eccentricity. I mean, they're all fucking eccentric lunatics anyway. So what the fuck is there to be afraid of? I mean, come on, just quit playing this game that they're, some kind of uptight, I'm scared of words. You might say the word fart or something, and I'll have a crisis. I'll have an emotional crisis and need to pet my security squirrel. What the fuck are you doing here, right? There's no conversation. Fuck this. I don't want to talk. I've already extended enough I've wasted enough words on making the point. All right? Messengers are supposed to be irrelevant if you're a smart person. If you're a dumb, motherfucking, conniving, cheating imbecile, well, then you give a fuck about the messenger because it's the only way you can win the argument. But if you have some kind of thing called intelligence and integrity, you couldn't give a shit about messengers.
Processes are required to create life. A key factor to remember is that although gravity is weak, its effect is unceasing. Over long periods, even the weakest force can produce profound consequences, as demonstrated by the transformation of that featureless void into the intricate universe that we see today. It all began with singular particles clumping together, which in turn created strong gravitational forces that dragged in more.
So again, they keep saying they know this for a fact, that somehow the universe had an origin, or somehow it banged this, and it did this, and it contract. No, it could have just done this expansion and contraction thing forever. If you understand that gravity, when matter's moving, it means less force is out there, right? So if I'm moving matter, you can understand there has to be less free force. So you can understand that the more the matter's moving, the less pressure can be on the outside, which means that more of the force moving the matter is going to tend to go outside because there's less pressure. And then as soon as it goes outside and creates more pressure, well, then it traps more motion. So it just keeps oscillating in this, back and forth, just like your ass is oscillating in your chair. It just oscillates between, gravity gets a little stronger, then gravity gets weaker, then stronger, then weaker. And the galaxies just expand and contract and expand and contract, and everything just does that. And it could do that forever. No law against it. No law against it.
This endless cycle ultimately allowed for the formation of stars, planets, solar systems, galaxies.
So this formation argument is just so, they don't believe that the motion causes heat. So they don't have any continuous where does the energy come from? So the obvious thing to state is that the energy goes into the earth, and it has to go back to create the very force that's pushing the crap in the first place. So the energy you're creating, the heat you're creating, excretes from the earth, and it might be pushing some... Well, it's theoretically absolutely true that it's pushing some rocks on Mars. Right now, your cell phone calls are hitting Mars, and they're pushing rocks into the center of Mars. So, that's all you need. You just need a mechanism, okay, that is complete. Their mechanism is incomplete. They have a magical waterfall, and a magical drain. And somehow it drains up back into the waterfall, but they don't describe it. They don't explain to you that it's a real force. It has to be a real force. It has to be something real that's refueling the system. I just don't know how people could see it any other way. Again, this is a big part of these basic statements I'm making. This is stuff I knew when I was 11 years old, okay, that they would say something, I'd say, well, that's not really how it works, right? They drew the wacky photon, and I was like, no, it can't be that. It can't be that snaky thing. How does it know how to do all that snaky crap? I can't do that. How can a photon do it? It was just so obvious their answer wasn't elemental. I mean, really obvious that it wasn't elemental.
It all took an unimaginably long period of time, or at least unimaginably long from a human perspective.
Fuck you.
The shaping of the universe is ongoing as we speak. If theory of gravity is an invisible force identifiable only by its effects in the physical world, you might be surprised to learn that gravity's fingerprints are visible.
So again, everything is only known by its effects. So that's all we know about photons. Photons have to create electricity, or we can't see them. Fact. It's just the truth. So we can only see anything because of the effects it causes, and what it causes electrons and protons to do something. If the electrons and protons don't do something, we can't know it exists. So duh.
On every level of the universe, from protostars on their journey to
so whatever this whole bull, this blah 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 blah.
Becoming full-fledged stars, to the contours of black holes, to the very strong...
Oh, right, the fake donut picture. It's not a picture. And it was completely contrived out of just saying, give me data, and the data that looks like a donut I'll keep, and the data that doesn't look like a donut I won't keep. Jeez, what a surprise, it looks like a donut. You could make me look like a hobgoblin, right? You could just say, okay, we're going to take all these pixels that I'm making, and we're only going to keep the pixels that give me horns and 14 eyeballs. And those are the only pixels we're going to keep. Yeah, then I'll look just like a hobgoblin. Duh. I mean, it's just, the physics is so bad.
Of galaxies and solar systems, despite being almost inconceivable.
So really, the subject of gravity is as simple as, this event. And here he is showing us the universe, right? And all he should be doing is just keep doing this and saying, what the fuck is actually... Now, if a bent geodesic is doing this, it made this thing move. Holy shit. It made it move, and then when it hit, I still have to hold it up. So the force is still acting on it, because I got to do work to keep it up. And so how could they be making this argument that this is some bent geodesical thing? There has to be a mechanism that's giving it momentum. It can't get momentum from nothing. It has to get momentum from something. And obviously the only way you can make heat is you have to use something's momentum. There's no other way to make heat except to use something's momentum. That's it. There's no other way. Alright, so what's this guy say? You could actually study these things. Oh, fuck you. Yeah, I've studied for 10 years, 15 years now. There are places where you can ask for help and understand these things. Fuck you. Get what you deserve, you trite puke. I could defeat you in any one of these subjects. Do you know who Madame Chartelet is? Do you know what denting clay experiments are? Do you know who Leibniz is, you lying little sack of turd? Oh, just fuck off. You don't have a counter argument. Alright, so let me see. I should be able to moderate him out of existence. Yeah, so fuck you, cunt. I'm going to moderate you. Oh, come on. I'm supposed to be able to moderate. Where's my moderating power, YouTube? Oh, shit. It's got to be the little thing with the dots isn't opening anything. So maybe it's that the stupid... Oh, there it goes. Okay. Let's see. Put user in a timeout. Fuck you. Just die. Yeah, fuck you. So good. We're not going to waste a whole bunch of time on trolls. If you can make a specific argument or link to something real, fine. But if you can't do that, fucking die. All right. Hardly. Because you really don't know what an argument is. You have to counter my statements. That means you quote a statement, you say, I can prove that's not true. Well, go ahead and try to do that. Okay? But you won't succeed. And then again, you have to understand that I have made thousands of videos, specific subjects. You can search my channel for double slit and you'll find 200 videos describing all kinds of aspects of the experiment. Alright, and obviously the most recent ones are going to be the most complete ones in terms of destroying completely any notion of wave-particle duality bullshit. But you have some responsibility to do that coming into this room. To appreciate that this isn't my first video. You fuckers. Oh, God. Humans are just such dirt. Oh, where was I? Yeah, back to the shitty video. Oh, God.
There is simply no escaping gravity or defying its effects. That said, you might be struggling to understand how...
Right, you can't... How do you escape a photon either? You can't escape photons either. You can't escape magnetism either. There's no anti-magnetism ray. There's nothing. You can't escape the fact that force affects electrons and protons, and you can't make the force poof away. You can't hit the force with a force and make it go away. Fact. Gravity doesn't bend light. Okay, it's another just. Again, the Eddington experiment was absolute bullshit, and all those lensed images from space are way out of line with any kind of mathematical reasoning. There's no way you can make them mathematically coherent. And the only way they pretend to make them mathematically coherent is to create this fake dark matter crap that doesn't obey the laws of gravity. Ironically, it stays in places where gravitationally it can't stay. So it makes no sense at all. It creates gravity, and yet it isn't affected by gravity. Isn't that amazing? They invent this dark matter, and it makes gravity, but it's not affected by gravity. I mean, isn't this Holy Ghost made up shit? How can you not notice that that's Holy Ghost made up shit? I mean, I just don't know why you people believe this crap. The answers are so crappy. Why do you believe it? It's just so depressing that you are such dupes.
Gravity operates on both extremely small and vast scales, especially knowing that the same rules govern both planets and entire galaxies. So there's another mind-bending aspect of gravity to consider. Like electromagnetism, its reach is bio...
Right. So what's the point? Yes, well, no, they all reach forever, so to speak, theoretically, in some... broad sense that you can't, obviously if it's a field of particles and it's getting fewer and fewer as you're spreading it over thinner and thinner distance, there are some vectors where, the photon can't possibly go there because there's no energy going there. But a minute later, there will be a photon going there. But at this one moment, there's no photons heading that way. There's none that will hit that target. So, yeah, there's a way of saying that it doesn't go forever, but there's also the point that if you wait 1 billion years, a photon will eventually hit. If I put a mouse 1 trillion light years away, okay, eventually a photon from Earth will hit the mouse, but it might take 1 trillion years.
What counts in evidence?
Grammarly helps me get the best grades possible while depleting the least amount of hours of my week. I'm Lauren Taylor. I'm a student and future CMO, and I am a Grammarly user. Grammarly's AI Compose can help.
She's gonna make her own little business. Of what?
So,
sitting on things?
A frequently drawn comparison between the words of fictional Jedi Master Obi-Wan Kenobi and the real description of gravity. Obi-Wan explains that the Force is, quote, an energy field created by all living things. It surrounds us, it penetrates us, it binds the galaxy together. If you replace all living things with all objects with mass, well, you have a remarkably fitting description of gravity. While Obi-Wan never specified the reach of the Force, one can only assume that, like gravity, its influence is boundless. Now, it's incredibly difficult to grasp the concept of infinity. Most people tend to dismiss it as a fantastical idea, since very few things in reality have no limit. Yet the range of gravity is, for all intents and purposes, described as extending to infinity. This means that every object with mass exerts a gravitational effect on every other.
So it really isn't true. So the fact is that Andromeda, its distance away, the gravity is just photons reflecting off of me, you could argue, or I am emitting a little bit of heat. The odds of my heat hitting Andromeda, okay, any element of it, is extremely thin. That is, in the next 1 billion years, no photons from me will hit it. I need tens of billions of years before one photon emitted from me actually makes it to Andromeda. So this is just all bullshit. So obviously it's infinite potential. It has to be understood in the context that needs an infinite amount of time. So, it really doesn't reach everywhere in any frame of time that we exist in.
Object with mass across the known universe. When viewed on this scale, it is truly mind-boggling to comprehend just how powerful gravity is and how fundamental it is in the structure of every object in existence. That being said, a bit more explanation is required.
Who writes this tripe, right? This is just like, that's just religious talk almost again. Oh, it does this. Is just really fantastical and magical and fantastically magical. And it's just so it's just something falling a straight line towards the center of the earth. It's just, why all this phantasmagorical implication talk?
A key factor to consider is that gravity, like everything else in the known universe, cannot travel faster than the speed of light. Furthermore, the strength of gravity decreases exponentially the further we move from the body of mass. Although its reach may technically be infinite, the overall effect of gravity becomes almost non-existent at a certain.
Well, he said, he just used the wrong word there. Okay, so he just said it wrong. So let's go back.
Exponentially.
It's not exponential. It's quadratic. The inverse square law is quadratic. It's not exponential. There's no other thing but the inverse square law. Gravity obeys the inverse square law. It's quadratic. So, they can't even use their own technology terminology correctly. Exponential would mean it could be almost any, 10 to the 50th or something. It's not exponential. It's very narrow. Quadratic, that's it. Squared. R squared, not R quadratic. Alright, let's see. We got a poly bill. I don't know what that means, but okay. Oh, you retracted this message. I know you have a learning disability, but please, yeah, just fuck off. You know, die miserably and horribly as you deserve. There. You know, because I say so. Please do it because I say so. If your cells can hear me, destroy him. He's an asshole. He can't do humanity any good because he can't make any arguments. And he has a micro penis, so he's already out of the game anyway. He might as well be dead because he has a micro penis. He's just, these people are just amazingly weak. Ugh.
The further we move from the body of mass. Although its reach may technically be infinite, the overall effect of gravity becomes almost non-existent at a certain distance. As far as speed is concerned, it's well documented. Both the light from the sun and gravity travel at the same speed, arriving at...
Right, so he just conceded. Oh, the infinite force. Well, yeah, it's not, realistically, it's not infinite. It's just too silly.
Earth in around 8 minutes. Taking this into account, the gravitational influence of any mass will only travel a set distance in its lifetime, and it's important to remember that bodies of mass tend not to simply vanish, but instead transform into different forms. Regarding strength, gravity operates.
What does that even mean? They transmutate into different forms. So he just said, it was exponential, and now he's drawing quadratic. So that's the simple, the inverse square law. I wish they would just teach it this way. It's just so simple. It's not a mysterious thing at all. Light bulbs are doing it. I mean, it's happening all over the place. It's just this, spreading this way and this way. That's the square. That's the square. You can't make a square by just going this way. You have to make the square by going both ways. Oh, it's just so obvious.
It's based on the square law, meaning that the gravitational pull weakens in proportion to the square of the distance. In simpler terms, every time you double the distance from mass, the overall strength of the gravity it produces drops off by a factor of 4. When this principle is applied across the vast distances of the universe, the force never truly reaches zero. However, it eventually becomes so minuscule as to be just negligible.
There you go. Okay, so he's saying it again. So it's the third time he's brought up the subject. And wouldn't be the simple analogy be a spray can? Right? Paint spray. So theoretically, if you have a good nozzle, it leaves in a cone that will be the inverse square law. So the paint will come out, and the further away you are, this little paint particles are spreading in both dimensions, and so you'll duplicate the inverse square law. So the same exact rule applies, and so you can understand that, yeah, well, if I spray paint over here, and I'm in New Jersey, it's really unlikely that any of the paint's going to get to California. Now, obviously, the paint is matter; it can't go through the atmosphere, frictionless, and or any of that. But let's just say if it was frictionless, you could understand that there's going to be a very low probability that I'm going to get a paint particle to land in California.
To look at it another way, it's the biggest body of mass in any given location that has the most tangible effect, overcoming smaller nearby bodies of lesser mass as well as larger bodies that are further away. It is, according to these rules, that galaxies and so...
It's happening to individual objects, okay? They don't... There's no shared gravity or any of that horseshit. Each individual object, matter, thing has its own gravitational field, and that's it. There's no other anything, okay? And obviously everything else is affected by other gravitational fields, but they're not combined. So when Newton combined the moon and the earth, he didn't need to do that. The simple equation is g times the mass of the object, and that's it. You don't need to combine the moon, because all you need to do is say the moon is g times its mass. They're two separate frickin' objects creating two separate amounts of gravity. I mean, it's just they did mass times mass because they're basically just saying I'm only going to multiply the g times the both multiplied times each other. And instead, you could just change the formula to G times the Earth's mass and then plus G times the Moon's mass. And understand that's the better formulation because that's the one that's more real. That's what's really happening. The Moon creates a gravitational effect. The Earth creates a gravitational effect individually.
The systems take shape regardless of each individual field of gravity having enormous range. Now, at this point, you're wondering what effect gravity in your body has on other humans, or what effect it might have on the universe at large. Consider that although your body does produce gravity, the effect is virtually immeasurable. We can estimate this effect based on established formulas. The gravitational pull between a body and an identical body, assuming you're 100 kilograms, alright then, equates to 0.0000000417113 newtons. This number is then reduced by a factor of 4 with every doubling of distance, reminding us once again just how negligible gravity is in most cases. So there is another effect that your body and all objects with mass
So there's no point in saying that just gravity is negligible when we're obviously experiencing it, and it's a huge pain in the ass in the sense that it's basically saying, space travel is going to be really difficult because, you're going to have to waste an awful lot of energy just getting out of the gravity.
Experience. This topic will officially transition us from viewing gravity as merely peculiar to considering it downright bizarre.
All right, so again, there's nothing bizarre about it. We all live with it our whole lives. It becomes very familiar, and like I said, there's a certain simplicity to it. I mean, it always does the same stuff. I mean, I don't put something in the air and it just sits there. So I mean, it always works.
Of course, talking about time dilation, an effect that most acknowledge exists, yet one that is often fundamentally misunderstood.
All right, so there is no time dilation. And the only question is what happens to matter when you move it really fast? And the fact is it probably just breaks. But, I mean, the only way you could get to the future is you have to just go to sleep. So you could argue that, okay, there's this time dilation where your mass all moves slower, your electrons and protons all move slower, you breathe slower, your eyes blink slower. No evidence that happens at all. So you have no proof that, like, an apple will rot slower if I shoot it into space at a speed or something, that all the microbes will chew slower and everything will be slower. No evidence whatsoever that any of that happens. And all of this is based on the fact that they're saying somehow, that atomic clocks are indestructible, that you can't break an atomic clock. And the simple argument is yeah, you can. You just give it velocity. And it's the same argument that has to do with the fact that we know that nuclear decay is controlled by the environment. We know it's controlled by some element in the environment. Because I put isotopes close together, they decay quicker. So obviously it's the environment. So obviously if I can move a decayable isotope, there's a high probability that that motion is going to distort the electrons and protons and might change whether it's going to decay or not. So, and there's every reason to say it could make it decay quicker or it could make it decay less quickly, because now it has a pushing force that's, distorting its shape, and so now it's not as breakable. It's under higher pressure. In a sense. There's some materials that are stronger if you apply pressure to them, so that would be the argument. So that you could just say that these nucleuses become more stable when they're moving, and that simple explanation blows up this whole time-space thing, bent time-space-time thingy. You don't need any of that crap if you just understand, atomic clocks are affected by velocity. And then you say, well, look, I have an atomic clock on Earth. What's it doing? Well, as I pointed out, you're getting pushed into the Earth, and the Earth is pushing you back up, and you're doing this. And you're in heavy gravity, so you're doing this a lot. And then if I put you in a satellite moving 5,000 miles an hour, which seems like it should be faster, well, you're actually going slower because you're doing this. Okay, so your actual path when you're on the surface of the Earth is really a big, giant path, so you're going very fast. And when you're in space going 5,000 miles an hour, you're not going much slower because you're at least less. You're going up and down less. So, and that's the truth of it, okay? So the time dilation is about the fact that it's the Earth clock that's going slower, not the one in space. So the one going 5,000 miles an hour, that one somehow isn't going slower. It's the one on Earth. Somebody typed a bunch of crap that they deleted. Okay, the gravity equation you just gave is simply... It isn't wrong. What the fuck are you talking about? How is it wrong? Yes, I left out the inverse square law. Obviously, both of them are inverse square functions. But where are you saying, if I multiply g times m1 plus g times m2 over r squared, how is that wrong, you dumb fuck? I mean, you obviously don't know any math. It's exactly the same fucking equation, you fucking idiot. The answer would be exactly the same, you fucking dumb cunt. Jesus Christ, these people are just such scum. Oh, I hate humans. Hate them.
It turns out that we all experience time as moving slower or faster, depending.
I mean, do we really have to write it out? I mean, do you want me to rub this in your fucking face, you dumb cunt? Oh, God, I hate math. I don't have any, I don't think all this needs to be complicated math. MV equals MV. MV in equals MV out. That's the only equation you need to know to understand the entire fucking universe. Because that's the only thing fucking happening, is masses moving velocities. That's it. And all you can do is exchange the goddamn motion, the quantity of motion, as Descartes called it. Descartes was right. You are assholes. So look, I can change this moronically stupid formula, okay, m1, m2 over r squared. I can simply rewrite it as, let me fix this so you can see any of this shit. Yeah, you can see it. I just rewrite it as g, okay, times m1 over r squared plus g times m2, right, over r squared equals the gravitational force, small g, over time. Done. It's the same fucking equation, you fucking asshole. I just... people. Hate them, hate them, hate them, hate them. Human beings are just such scum. What the fuck? Yeah, what the fuck is this image? Oh, it's a guy climbing a rock. Oh. Alright, let me see. No, you can't rewrite. Alright, so you're done. I'm done. I've already proven it. You're wrong. Okay, you won't admit you're wrong, then fuck off. Okay, goodbye. You're wrong. You're absolutely 100% fucking goddamn wrong. You arrogant asswipe. I mean, it's just so funny. I hate math. I'm terrible at it. And this asshole is going to say those two formulas aren't equivalent. This isn't exactly equivalent to this. I mean, this r should be squared, of course. This is exactly equivalent. I get exactly the same answer. Same answer. And to me, this is the accurate formulation. They're two separate things. The moon's gravity, the Earth's gravity. Combining them makes it look like they are dependent on each other, and they're not. Sorry. Needed a refuel.
factors from our location on the planet to our speed at any given moment.
So this is just a waste of time, right?
Grasp time dilation and its underlying mechanics, it may dawn on you that the very notion of keeping time is, technically speaking, completely meaningless.
I mean,
Look, Mom.
Wow! Ugh, wish I bought Dixie. These weeks store brand.
I mean, to call time meaningless is just so idiotic. I mean, the whole universe only exists because there is no instantaneous speed. So it is the very fact that light travels slowly, is why there's a universe. Everything would happen all at once. Nothing could ever happen because everything would have to happen at the same time, and everything can't happen at the same time if you have to move over here and then move up here. Well, you can't do that in the same time, so there wouldn't be any action in the universe. And obviously all of these things are a sequence of events, so if you believe in cause and effect, I mean, I just can't believe I have to have a conversation with people that are supposed to be science lovers, and I have to defend cause and effect. Like it's somehow, well, they never proved that. I have to argue it. So that's the new religion, is there's no cause and effect. We poof things into existence all the time, and then we poof them out because we don't give a fuck about logic and reasoning. We'll go with the most improbable, silly theory possible. So if you contrive an impossibly silly, moronic theory, we'll just love it to pieces. I hate this planet.
Gravitational time dilation. Now, time dilation, fairly straightforward in principle, summarized by Einstein's well-known theories of general relativity and special relativity.
Okay, so it really isn't. There's nothing, and there's nothing about Einstein's field equations that have anything to do with reason and logic. And there's every truth when you go ask real mathematical experts. They'll actually say, okay, I found a forum where they were talking about it, and they're basically arguing over the point that, well, what's Einstein's tensor really do is it moves the sun. And so, if you move the sun, you're going to move Mercury because it's so close to the sun. So if you actually move the center of the sun, you'll move Mercury. You won't move the rest of the planets because they're so much further away. It's a tiny bit of movement, right? You only need a little bit of movement. A little bit of movement, Venus isn't going to feel it because it's like, I don't know, 15 times further away than Mercury. So, I mean, the amount of distance between Mercury's location and every other planet, the rest of the planets are way far away compared to Mercury. It's so much closer. So, Mercury's like, this is the sun. Mercury's like here. Venus is here, and then the Earth is like here. So you get there. These planets are really close to each other. Mars, Venus, and Earth are really close to each other by comparison to Mercury. Mercury's really far away.
Referring to general relativity and taking into account...
All right, we really don't want to do this, right? I mean, it's not the subject of gravity anymore, so fuck it. I take time dilation, what a waste of time. So I'll just jump through this.
Roughly 10 nanoseconds long.
Yeah, fuck it.
Gravitational time dilation.
Oh, fuck it.
With the two relativistic forces counteracting one another, the GPS satellite gains roughly...
So there's, experts in GPS will tell you they don't use Einstein's equations, they don't calculate that, they just turn the knob on change the time. They don't bother with any of this crap. And if they did bother with this crap, it doesn't get exact enough answers to be useful anyway. So there's no point in doing it. It doesn't mean anything. It doesn't work. Yeah, that's the simple answer. It's bullshit.
I found out that if you mix ice-cold water with 3 other ingredients and drink it at a specific time of day, you can lose so much weight it looks like you went...
I wish it would. It's just too bad it didn't kill people.
Around themselves. This warping is what makes gravity so peculiar and distinct from the other forces.
Okay, so this is just Blender images, so there's nothing to do with reality here. There's absolutely no evidence this happens, and they could see this, right? So this is the big joke. There's 400 times better resolution in space. If they did this with the sun, that is, they just took a camera, looked at the sun, just had a little circle to wipe out the sun itself, and just looked at the black space around the sun. So as soon as you put a filter in front, I just put a round thing in front of my lens. I've blocked out the sun, okay, because it is all straight line force. It's gone. The sun's gone. And all I have is black space. So in space, you don't need an eclipse to see all the stars around the sun. And so they could do this right now. NASA could do this image, and it won't do it. It's never produced any such image. And they could prove, they would do exactly what they're claiming here. If their truth was true, that is, if the light was being bent by the sun's gravity, they would get an image that would have those distortions. They could just run the camera, all right, and they could actually, if they move, they have to move this with the sun, so they have to actually, keep the sun in the center of without distorting its view of the stars. And the fact is they should be able to duplicate that image. They should be able to actually make a video of us, and they could speed it up, and we should be able to see the stars doing all kinds of wacky shit. It's a perfectly doable experiment. Why haven't they done it? And Einstein suggested you could probably do it with Jupiter. Because it's a fact that you don't have the corona. You got, you have a lot, the sun's gravity on the surface is only 80 times what it is on Earth. It's not, it's not all that. So it's 1,000,000 times bigger than the Earth, but its gravity isn't 1,000,000 times stronger on its surface. And so planets like Jupiter that have like 40 or 50, as their gravity on the surface, but they don't have any, there's no radiation shooting out of Jupiter at this huge rate. They're not on fire. So you could actually, you don't have to worry about the sun's corona, a bunch of electrons, protons, plasma. You don't have to look through any of that shit. They never tried. None of you have asked yourself, well, why don't they do these experiments? Why haven't they done any Eddington-style experiments from space? There's 400 times better seeing. You can see better. 400. Okay, don't be confused. Not 4 times better. Not 40 times better. 400 times better. Oh, this is such terrible science. It's just tragic that people will defend this horrible science.
Thus,
this is religion. That's all it is. Physics is a religion. Oh, I forgot to retitle the video. Yes, that just reminded me. Maybe I'll do that. Where the hell is it? Well, I'll do it later. Yeah, I can't even find it.
even though light has no mass, it is still subject
Probably worth changing the date, but yeah, people aren't going to read it anyway.
of gravity. And when you stop to really think about that, the idea is kind of enough to melt even the steadiest of minds.
What the hell is this crap? Jesus, who's this douche? Oh, I hate it here. Okay, saying GM1 over R squared and GM2 plus, yes, is the same as, is like saying 1/2 plus 1/2 is the same as 1 times 1/2. They are not. It's not, it's not true. You obviously don't know how to do math, Mr. Math Help. I'm sure you don't have any real Math Help channel. You're just a spammer who's just invented a name to make this comment. So I don't, what, I should wait for a real mathematician to tell you? No, they're perfectly equivalent. If when the G's on the outside, okay, I put the G out here on the outside, okay, of the fraction, it means essentially that that's all you're doing. You're just doing the multiplication of the masses and then the multiplication of the g. So all you're doing is just changing where you're putting them. So you're just wrong. I'm sorry, you're fucking wrong. I'm not going to waste time explaining math because it's not even my expertise, but I know this much about math. I got a B plus in trigonometry in high school. So, fuck you. You're wrong. Ugh, you're just fucking wrong. So either shut up or fuck off. Replacing, doesn't matter what you're replacing. I'm just saying they're just functions. It's plus and minus and multiplication. I mean, do you not understand these are simple functions? Oh, it's just, just amazing how fucking stupid people are. God damn. Let's see what he says here. You never studied math in high school. That's clearly... just fuck off then. I mean, it's not clearly a lie because I fucking goddamn did it, jackass. I was there. I know I did it, shithead. And I know it was a low subject. I got one of the best grades in, shithead. Amazing. Continuing? I don't know if it's worth it. Oh, look at the smiley face. So again, this lensed image shit is just so bad because this is not symmetrical. This is not symmetrical. You can't have a strong semi-spherical gravity, all right, frankly. It's not going to come out that way. If it's a strong enough gravity to bend light, it's going to be very symmetrical. Because that's why everything's round in space. Suns are round, Earth's are round, Mars is round. They're all round. Pluto's even round-ish. So it's just stupid to say, oh yeah, the gravity's not going to be round. Yeah, it is. And it's going to be symmetrical. And the gravity's also not going to be able to lens a galaxy. So you're not going to be able to see little individual stars and all that kind of shit. Because gravity isn't a magnifying lens. It's exactly the opposite of a magnifying lens. So you can't magnify the light being produced by that galaxy. It's impossible. Because there's only a tiny little thread of space where the gravity is the right gravity to send an image to you. And it's so small that you won't be able to see it. And that's what Einstein said. So they don't even believe in Einstein's own theory. They've never probably even considered what Einstein said. But Einstein said you would never see an Einstein ring because the amount of space that it would be created by is so small that not enough photons could travel through it to be bent to you. It's impossible for the photons to be there to be bent. All right. So enough of this shit. This is, just this isn't the subject of gravity.
I told viewers that the road...
Yeah, fuck you too. Ugh, scummy scum everywhere. Alright, so enough of that crap. Oh, God, I hate this planet. Alright, so we'll do some chatters and that'll be it. See if anybody's got anything to say. And I'll just get the hell out of here. Not much interest tonight. Did better last night, frankly. Let's see. What do I need to go to let's see what the hell's in the room. I have to have 4 browser windows open to keep all this shit running right. 10, yeah, so it's lower than yesterday. So, yeah, that's not, tough shit, I guess. Yeah, right. So let's see, maybe I should fix this title anyway. So I'm putting something like 24. Yeah, is that what the date is? I don't know. It's a different number anyway. Is this the 4? Yeah, 44. Cool. I guessed right. Alright. The junk science of physics. Yeah, well, we'll leave that part. I'll change it later, maybe. Fuck it. Alright. So, pop-out window is... Where the hell is that? What's this? It's a play button. Yeah, that's the pop-out window. Strange. Alright. Let's see. I've contacted a YouTube channel called VT Physics. I think I've also heard of that. Hopefully she takes a look at your channel. There's no chance. She's a little Japanese woman? Or whatever she is. She looks like she's a 14-year-old boy. Yeah, I think that's the channel, actually. Let's see. She has a following and mainly creates YouTube shorts. Yeah, exactly. So, no point, right? Physics isn't a shorts subject. It really isn't. No. I mean, you're really not going to get to a right answer doing shorts on physics. It's, I've done a couple, but I mean, it's just, you really can't do justice to any of the subjects in a short. It's just not, it's not scientific. Yeah, let's just put it that way. It's not very scientific to do physics shorts as your only videos, really. If you're not going to make the hour-long version to go with the short, then you're probably not doing good science, in my opinion. Yeah, well, I'm just, I was so surprised, okay, was that, look, I've done this, I did all this hard work. I literally did spend, 6, 7, 8 hours a day drawing physics arguments and trying to come up with ways to make particle physics work. And then when I found solutions that worked, I thought all I have to do is show people this, and I did my job. I'm done. And I couldn't believe that you show them and they don't care. I mean, I've got a working simulation. I've shown it to people. You've seen it, right? Let me load it. And it duplicates charge beautifully. I mean, it just needs a couple of little tweaks to be finished. I mean, I just have a little obviously people have time constraints. I mean, I can't ask somebody to just do this for free, so yeah, it's been a little bit tricky getting it finished. But I mean, the fact is it duplicates, the function perfect. And, you can't, and you're just saying, well, how come people aren't like saying, Jesus Christ, it's amazing what you just did. You have created a perfect duplication of the function of charges with these simple little rules, 2 + 2 + 3 physics. 2 kinds of force, 2 kinds of matter, 3 kinds of interactions, and it works. And you can't get people to acknowledge that? And it even has the working part in the sense that it shows that they don't just crash right into each other. It takes time because they're in a noisy environment. And they can't just crash into each other because they're being moved in all kinds of different directions, and so they have to inch their way closer and closer. But the fact is, you let this play and it will create, blue, red, blue, red, blue, red, blue, red, blue, red. It will create a perfect magnetic model. It'll construct nucleuses. So I thought, well, I have to show people this, and they'll be like, shit, look at that, you did it. And not one single person did that. Not one person's reaction was, look at that fucking shit, he did it. I mean, Piro, no, unimpressed. Nobody impressed. Nobody saying, holy shit, it's working. It's making fucking, look, it's making neutrons. It's making neutrons. Nothing. So yeah, that amazed me. It amazed me that scientifically interested people don't really give a shit about physics or science. They want to believe in a religion. They don't want this to be true. This isn't the answer they want. This isn't woo. They want a wooey answer to what runs the universe. They don't want this mechanical system running the universe. Now, obviously, you see, this is the newest version of the simulation. It has these huge flaws where it's square, which means it's really not random anymore. So it doesn't work as well. So we have to go back to a round one, and with these better features, so it's just, these are tiny complaints, but I'm just saying, the guy's done this for years for me, 4 years, 5 years now, so I can't really complain. But yeah, I mean, it should be finished by now, and it's still not quite finished. But you get the idea. You see it right here now. I'm just saying, if we let this play a while, these two things will move up here. See, they're in the wrong order now. They're looking, the green one seeing the green one, and yeah, that ain't going to work. So I can turn off things and make this even more visible. Only red, let's see. So if I turn on just the red, now you can't really see anything. So that didn't work. Changed is interesting. So these are the ones that they go in blue and they come out red, or they go in red and they come out green. So that's that feature. Released. There should be a way to just make the green ones or the red ones. Draw vectors. No. This is what? Fill. Oh, okay. Yeah, it looks a little better filled, I think. So yeah, these are the changed ones. I'll turn that off. But if you could really see, like in the other one, you could really see where the red actually is just reflecting red, and the green is only reflecting green. So you actually see it in the field, where around the red object it's redder, and around the green object it's greener. Let me just randomize these up a little bit and see if we can get them to move about a little bit more and do something more interesting. All right. But yeah, so, I'm just saying, I can't believe that scientifically minded people can watch this simulation with these simple rules, duplicate charge, duplicate magnetism, essentially, south-north monopoles, and not be impressed. But that's how it is, because again, they don't want me to be right. That's the part. That's the whole. They just don't want me to be right. Oh, it just sucks. People are just so sucky. All right, so let's see what he said to that. Tomato juice, really, I don't think it's impressive. What does that mean? Let's see, and you are just absolutely wrong, both about math. About? You can't even say about. Give any values for G, M1, M2, and R squared and put them in a calculator. Well, whatever. I don't, well, whatever. I'll do it later. Okay. But I'm just saying the principle is that I'm saying Newton's formulation is actually wrong if it doesn't get the same answer. Because this is really the truth. This is what happens. The Earth's surface gravity is, 9.8 meters per second, and this is how you understand that. And the Moon's surface gravity has its surface gravity, and that's how you understand that. So, and they don't change each other's gravity. They just don't. Yeah, I'm just saying, see, the other version, it made what are called deuterons quicker. It would be electron, proton, electron, or proton, electron, proton. and it made those much quicker, and it did go together. And the only reason why it's not doing that better in this is because it's a square universe, and that was a mistake. Whatever. I'm not going to argue with you, tomato juice guys, so just fuck off. All right. The principle is right in your face. Okay. The G is the constant. The masses are independent. They're not shared mass. The Earth and the Moon are not a shared math. It's not a shared system. They individually create gravity. They have no collective gravity. So fuck you. Just do something else with your time. Let's see. I'm just curious. So let's say G is 1, just to make it impossible to screw anything up. And M1 is 1, and M2 is 2. And we have R squared, which will just make, doesn't matter, because that's a constant, so we won't bother with it. It'll be a constant for both. So we have 1 times 2 is 2. Times 1 is 2. Alright, and let's do my version, which was 1 times 1, and then 1 times 2. So 1 times 1 is 1, and 1 times 2 is 2, and 2 plus 1 is 3. So that's the difference. Yeah, it's 3, because it's plus. So, alright. So I'll concede that argument, but that's using ones. I guess I should use some other number. So I'll use a 2 instead. Okay, get rid of the 1. Let's see. So it's 2 and 2. Yeah, they can have the same mass. That's no rule against that. So 2 times 2 times 1. Okay, so that's 4. And then I have here 3, let's see, 2 times 1 is 2, and plus 2 times 1 is 2. So now I do have the same answer, 4 and 4. So fuck you. Yeah, there you go. It's always dangerous using ones in, as replacements, because of the, it's, ones are weird. Multiplying by 1 is a weird concept. Let's see. Yeah, you don't have to keep harping on it there, dark guy. I'm you really didn't offend me. It's not, it's no big deal. I was just arguing the sentence you wrote. I wasn't arguing that you're wrong or you're an idiot or any of that crap. I'm just saying, I'm not apologizing for having a personality. It's just not going to happen. I'm not going to apologize for that. And I don't care if it's a personality people don't like. It doesn't bother me any. Because frankly, I don't like them either. What's to argue? Let's see, is this a usable bottle of juice? I don't know. I don't think there's anything in there, Gary. All out of nicotine. Well, I'll just burn some stuff. Inhale charcoal. Extremely harsh. Ugh. Yeah, I'm gonna go refill the bottle. I'll get out of here soon anyway. Things is a bit slow. How much different would the simulation function in a 3D sphere universe and one without that? Well, obviously, you know, simulating it in 2D, okay, with 10,000 force bits is already a little bit demanding. So yes, 3D is so much more complicated, you know, in terms of just doing all the math. I mean, you have so many. I don't even know how to describe it, right? I mean, the 2D model is about, what, 1,000 or 10,000 times simpler than 3D in terms of how many locations you can have and how many different angles the energy can come at. So I'm just saying it is a, you know, it's a it's a pretty difficult chore to do this first step of the most elemental functions. Now, if I could generalize these functions into some simpler version, you know, pull out, so to speak, and, you know, do looser math to create the functions, well, then maybe. But in this tight universe, 3Ding is really going to be demanding. So I'm frankly, you know, it'd be nice, but it's just not it's not realistically going to happen tomorrow. So, you know, but it really wouldn't change anything. I mean, you're just saying that all you can, there's only the 3 dimensions, and the fact is, you can understand though, if I have 2 magnets and I want to, you know, get them stuck together, that simple principle applies. You know that, you know, if they're repelling each other or attracting, that the more they're moving in space, their line of sight is changing. Their force changes dramatically. So, you know, when I put 2 magnets side by side, the force is so much weaker than when they're directly, you know. So it's just, I'm just saying that obviously those features would become more pronounced, and so nothing would probably be able to get right next. The red would never get right next to the blue. They'd always be a little distance because they'd be constantly doing this shit. They'd be constantly moving in 3 dimensions. So they would never be able to just line up and stick. They would always be kind of a little bit away from each other. Kind of just blah, 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 you know, that kind of thing. But like I said, the simulation, when done right, already does that a little bit. You know, they stick together, but they don't stay together. They, you know, they'll bounce off, they'll move a little bit, they'll, you know, they stay much jitterier. I mean, I could probably, I can fiddle, you know, there's lots of options here. This guy really did a great job on this software. So I could make a lot more force bits. Yeah, a lot more. You know, and I could just bounce these around. We'll see where they go. And so he doesn't have the speeds quite right either. So a lot of it's a little bit fucked up. Oops. Yeah, something like that. See what they end up doing. But yeah, like I said, it's so simple. Like I said, if you saw the math for this, it's so simple. So you can see it has some exaggeration, and you get these very long lines, meaning that many force bits hit, and they really, it's not moving that fast. That would be like moving the speed of a gamma ray, and obviously it's not moving that fast. So it's hard to get the speed of the force versus the speed of the objects tuned exactly right. But you can see it's working in terms of its, you know, it's going to create clumps of matter. It's going to do what charges would do. Whatever, tomato paste he's calling himself now. So I just did the math. I just pointed out if I don't use a 1, the answer is correct. So I do 3 times 2. Okay, that's going to give me 6. Okay, So if I do 1 times 3 and 1 times 2 plus each other, that's going to give me 5. Well, whatever. I'm still right. Yeah, this is still the right formulation. I don't, I'm just telling you, it's the right formulation. It'll give you the right answer. The other formula isn't going to give you the right answer. Because the masses really aren't together. And the gravity is individually created by each object. Yeah, just fuck off, tomato paste. Look, we're already done playing this. Okay? We're done playing it. Yeah, done. 3 times 2 is 6. Yeah. 3 times 1. Yeah, I'm still using the 1. I guess maybe the 1's what's breaking it. The gravitational constant. I probably should use a bigger number. Really shouldn't matter though. But I'll try that later. It theoretically can't matter which one you multiply first. It really just can't matter. But anyway, it shouldn't matter. Yeah, I'll say that. Yeah, well, the speed actually isn't that incorrect. It's just that you can't really, a big object moving the same speed as those little objects is very distortive. Because you really can't see it. When the big object's doing the same speed, it doesn't look like it's the same speed. So it's an optical problem too. Obviously, the electrons and protons don't move the same speed as the force they're collecting. But the more force they collect, obviously the faster and faster they can go. So if you hit an electron with a gamma ray, it's going to go very fast. So fast that it's not slowing the force down anymore, ironically. Yeah, the force is almost going, it's going some 80% of its original speed, so it's actually consuming less of the energy of the force. The faster the electron goes, the less energy it's consuming. I mean, that's the irony of it. But you sort of see that with rockets. The faster you can launch the rocket, the less work you do against gravity. So it sort of connects to the other realities of efficiency. Alrighty then, well, we're running out, so if somebody has something else to argue, let me just try this math one more time. Alright, so I'll make this a 2, make this a 2, yeah, I'll make everything a 2, yeah, that should work. Alright, 2 times 2 is 4, 4 times 2 is 8, okay, so I get the answer 8. And then down here, I get 2 times 2 is 4, plus 2 times 2 is 4. I get 8. There you go. Okay, so it does work. Yeah, it does work. So it's the ones that fuck it up. If you use ones as a replacement for any one of the quantities, you get the wrong answers. But if you use something other than a one, they get the same answer. That'll be that's the argument I'll make. It really shouldn't be true, though. I mean, I should be able to make the gravitational constant a 1, and it shouldn't change anything. But it does. So the very fact that sometimes the two equations get the same answer means, who knows, right? And sometimes they get different answers. Which one's right? It would be the argument. And I would argue my formulation is correct. I just don't, I'm just not sure if I didn't even see, I saw my formulation somewhere else. I mean, I think it's, yeah, I'm just not, I have a vague memory of like, I didn't think of it, like I got it from some other place where I saw it that way and said, oh yeah, that makes so much more sense. But I'm not, don't have a secure memory. A good enough memory. Yeah, out of juice. Alright, so we're almost done, right? Almost done. Yep. Nobody's saying anything? Okay. So yeah, see this simulation, they really just aren't flying into each other, and they really should be combining into, bigger objects, but that's because this is on the wrong side. So if we put him over there, then there's some chance that this will see this and say, yes, we're attracted. But it takes time, blah, blah, blah. Alright, so let me see what this thing says. Yeah, the same 10 viewers, that's all we get. 10. Oh, yeah, it doesn't move much. Alright, there's quite a lag. Alright, so we'll just call that evening then. And so, no report on when the next one will be. Yeah, who knows. When I feel like it, I guess. We'll see. I remember when I used to do this, it was like this too. You just couldn't rely on there being enough of an audience to be worth it. But whatever. Because it does make a video I could have made in 30 minutes is now 3 hours long. Well, 2 hours and a half or something like that. Alright, so last chance for any comments. Let's see. Well, I'll keep finding other physics channels to check your stuff out. Yeah, I appreciate it. I mean, like I said, don't knock yourself out or anything. But yeah, it is a pain in the ass, and they just end up, your comments don't even show up, or they block them on, it's really pitiful that nobody replies. I mean, I gave Bruce Yearney some credit because he actually responded to the email. I mean, his first reaction was, who's sending me emails? What's going on? But at least he did get the idea once he saw the videos. He got that there's a problem, and it, he related to it a little bit. It's not the one that's the problem. I'm saying that's pretty close to the problem. It's the 2 plus 2 is the same as 2 plus 2 times 2 is the same as 2 plus 2. Yeah, okay, that's true. Doesn't change the fact that the formulas do sometimes get the same answer. So I'm just saying, you can say whatever you want. The two equations do get the same answer. So I'm just saying there is some reason to believe that maybe if you actually tested the two formulations, that one of them is more correct. But whatever. I'll try 2 and 3, and then I'll try 3 and 5, and then, we'll see exactly what combination of numbers are where this thing breaks down or something. But it is curious, little things like that in math where 2 plus 2 is the same as 2 times, 2 plus 2 is the same as 2 times 2, and obviously 3 plus 3 isn't the same as 3 times 3, so it is kind of funny. Let's see, 4 times 4, no, none of the others will ever work, so it's just a glitch with 2's, which is kind of funny. Frankly, I find it funny. With almost any values, the equations are not the same. Well, again, you keep telling me that. Fine. I'm just saying that I don't understand the distinction. And so you're saying that there's some reason, some good reason to multiply the masses times each other first, and then multiply times the gravitational constant. And I'm arguing that, well, frankly, that doesn't duplicate what's the actual physical reality, which is, it's just a fact that the gravity being created by the Earth is not dependent on the moon. And if I was to write the gravitational equation for just the Earth, it's going to be g times its mass divided by r squared. That's the actual gravity of the Earth. Well, you can't multiply them. I mean, it's the Earth doesn't multiply by the moon's gravity. There's no multiplication factor. It's not a multiple circumstance. They're two individual vortexes, or whatever you want to call it. I mean, it's a push force, but there's two things sucking, and each one of them has a sucking power. Well, I understand there's no plus in the other equation, but that's, I mean, obviously I'm changing the equation, and there's also two g's in my formulation, but that doesn't change anything, does it? You're just saying that it matters that you multiply the masses first. Isn't that all you're saying? Otherwise, it's the same formulation, right? I mean, it's g times m times m. That's all it's about. There's three multiplication factors, and you're just saying you have to multiply the masses first. Well, look, if you're going to do these silly little trite icon baby talk, then fuck off. God, make another sock account. God, you're such a petty turd. You're not understanding conceptually the argument. I just asked you clearly, why do you think the masses have to be multiplied times the masses first? So I'm clearly acknowledging that it matters in what order you multiply. But I'm saying, why do you think that happens? Why do you think that's the correct answer? What about the Earth's gravity is in some way a multiple of the moon's gravity? How are those two sets multiplied times each other is the simple argument to you, butthead. Because it's all the same thing. All you're doing is multiplying these three numbers. You're multiplying g, m1, and m2. That's all you're doing. And I'm just saying, well, you can either do it by multiplying the masses together, or you can do it by multiplying the g times each one of the individual masses. Ugh, assholes. It would just be interesting if they had some kind of proof. Yeah, and they don't. They'll just say, our formula is right. It gets right answers because we say so. I mean, the effect is irrelevant. The only way you can measure gravity is to watch the motion of the objects, and the motion of the moon is completely dictated by the gravity of the Earth. Well, I shouldn't say that. So that was a little unfair. Obviously, you have to combine the fact that the moon is also in a gravity well. It's got its own gravitational pull on the moon, on the Earth, but it's obviously a lot less. Well, it's not that much. I mean, it's 1/6, right? Alright, so I guess we're done. Blah, 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 blah. So, till the next time, and such. And so forth and whatnot. God. Look, he did it again. He made another sock account that quickly. It's amazing what YouTube allows people to do. I can't even access my channels, and this asshole can make new ones. YouTube doesn't let me make any new channels. It doesn't let me do any of this shit. How would it say it's a huge force? It's multiplied times the gravitational constant, and if it's a tiny mass, how could it make a huge force? You're merely adding it to the gigantic one that you've created, the first one. So you're wrong about that. I mean, what is, how does the tiny force become bigger by multiplying it times the same gravitational constant? Sorry, no sale. I mean, you're not explaining it. You're not explaining how that gets it, how a tiny thing gets to be a big thing because I added it instead of multiplying it. Obviously, multiplication makes a tiny force bigger. I mean, if I use your own formula and I multiply 1,000 times 1, well, I shouldn't use 1 again, right? Times 5, I get 5,000. Right? So with my formula, I get the tiny, whatever the gravitational constant is, which is a 1 in my case. And the other mass will be still the same number. So I don't know what you're talking about. How do I make the small force big? My formula doesn't make it any bigger. There's no way these two formulas are not going to get dramatically different numbers, right? They're just going to get numbers that are different by a factor of, a few percent. There's no point in doing a zero equation, is there? I mean, I'm not going to talk about a zero. There's no point. Multiplying by, we know multiplying by 0 is going to make a 0, so what's the point of doing that? Whatever, I told you we're done, and you just keep on doing this. All right? I don't know, I'm still going to argue that they're two independent gravitational fields, and you can add their effect, but there is no multiplication of their effect. So you can keep saying that somehow they multiply each other's effects, and I'm saying they can't possibly multiply each other's effects. G times m divided by r squared is the suck that one of them's creating. G times m2 divided by r squared is the suck the other one's creating. You can only add those two things. You can't multiply them. So, fuck you. You're just not getting the point of the argument. I was wrong to say they get the same answer because, yes, I'm saying that obviously they don't get the same exact answer. But I'm just going to argue that the right configuration of the forces is to understand that there's no point in multiplying the two objects because what is the multiplication indicating that somehow they magnify each other's force, and they can't magnify each other's force. The moon doesn't make the Earth's gravity stronger, and the moon doesn't make the Earth's gravity stronger. They can't make each other's gravity stronger. Okay, well, you can say it's silly, we disagree, so fuck you in the ass till dead. Go away, fuck you, I hate your guts. So what? We don't agree, okay? I think it's insanely nonsensical to tell me that this basic force created by a gravitational body is somehow multiplied when I have another body involved. That somehow if there's two bodies, there aren't two individual gravitational fields. There's two individual gravitational fields. You can't multiply them. So, fuck you, we're done. Just can't believe people can make these sock accounts, though. I mean, wait, is there software? I don't really want to go through the trouble of figuring out how they do this shit. But every time I try to make a channel, YouTube asks for a cell phone number. I don't even have a cell phone. I mean, I can't make an account. How do you do it? How do you make these stinking, lousy, rotten sock accounts? Why does YouTube let you make them? That is the bigger question. Why does it let people make these sock accounts? Really, it's just kind of evil. Alright, so we're done, right? Yeah, we're done. Alright, so I guess I will end the stream and such. So, till the next time and such and so forth and whatnot. Blah, 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 blah.